Hi. In this video, we're going to be looking at the so-called make it right technique of integration. This technique is a way of integrating rational expressions mostly. It can occasionally work for some other algebraic expressions as well. So for example, let's say we were looking at the integral of 2x plus 1 over x squared plus 8x plus 3 dx. Now, this looks so close to something I would love. If this were 2x plus 8 in the numerator, then I'd just be doing a nice easy u-sub. And so the make it right technique says, hey, the derivative of the denominator is 2x plus 8. That's what I want up here. Let's just have it. 2x plus 8 over x squared plus 8x plus 3 dx. And why do I want that? Because then I'll be able to look at that and go, okay, let's let u equal x squared plus 8x plus 3. Then du equals 2x plus 8 dx. And right away, we're practically done with this. We have integral 1 over u du, which is ln absolute u. So that would be beautiful. We're just making it right. We're saying, I want a u-sub. Let's make the numerator right for having a u-sub. Unfortunately, we can't just go around changing things, saying, gee, I wish I had an 8 instead of a 2. So in order to get that 8 instead of a 2, we really had to add 7 to the numerator. And that means we need to subtract 7 from that numerator as well. And while we were able to make that first part nice, this technique isn't going to make the second part nice. So this technique is a technique you can choose to use. Some people would have chosen to start by completing the square. Some people would have chosen to start by doing a partial fraction decomposition. Whatever you choose to do is fine, but choosing this technique says, I just want this part to be nice and neat and easy. Oh, I better convert that back to x, so eventually that'll be ln absolute x squared plus 8x plus 3. Okay, so we just wanted that. That part's nice. This part, not so much. I'm stuck integrating this using other techniques. I'm done with the make it right part of this. So what could I do for other techniques here? Well, one that comes to mind right away is completing the square. That might be a nice technique here. So in this case, looking at that linear term 8x, half of 8 is 4. 4 squared is 16. So what I want is plus 16. So that's what we get for our perfect square. Now to make that have a plus 3, really, I've got to do minus 13. That way we really just have the same thing we had there. And so this becomes the integral of 7 over x plus 4 squared minus 13. Well, great. How do we integrate that? Well, we integrate that using u-sub. Oh, it's not the same as that u, so I better give it a different name. Let's call it w. That's my clever way of dealing with a second u-sub. You could call it u2. You could call it anything you want to, other than x or u. So I'm going with w. I'm going to let w equal x plus 4. Then dw equals dx. And so we're doing minus the integral of 7 over u squared minus 13 du. Previously, this was dx. Now it is du. Well, the question now becomes, how do I integrate 7 over u squared minus 13? Well, u squared minus 13, oh boy. Unfortunately, that's not an irreducible quadratic. It can be factored. And so as soon as I can see that can be factored, and it factors as, let me copy the whole thing down again just for fun. It factors as 7 over u plus root 13 times u minus root 13 du. And so seeing that factorization in the denominator, I go, oh, that looks like a partial fraction decomposition situation. So let's do a partial fraction decomposition. Now, I'd like to do this as side work so I can stop copying the whole thing for now. So just some side work here. If you're doing this on a piece of paper, then make sure it really is off to the side, out of the way. I normally would do it off to the right over here, but I don't think I quite have enough room. So here's our side work. We have 7 over u plus root 13 times u minus root 13 equals a over u plus root 13 plus b over u minus root 13. And you might notice that the numerators are both constant terms, a and b. That's because the denominators are each linear. Also, nothing was repeated. I didn't have a squared here or a cubed here. So again, that's the entire partial fraction, the form of it. Now to actually find that partial fraction, we get that 7 equals a times u minus root 13 plus b times u plus root 13. And so we get that 7 equals au minus a root 13 plus bu plus b root 13. Combining these, we get 7 equals a plus b u w. I'm sorry, these have been w's. I messed that up some time ago, didn't I? So a plus b w plus negative a root 13 plus b root 13. All right, that means that a plus b equals 0 because there is no w term over here, but there is over here. And negative a root 13 plus b root 13 equals 7 because that's a constant terms, that's our constant. I'm going to get rid of that root 13 here, so we get a plus b equals 0, and multiply both sides by root 13, or divide both sides by root 13. I think I'll do that. So we have negative a plus b equals 7 over root 13. We can solve this. Let's see, 2b equals 7 over root 13. That means b equals 7 over 2 root 13. And now we can find a. A is negative 7 over 2 root 13. So we can come back up here to our original work, ln absolute x squared plus 8x plus 3 minus the integral of 7 over 2 root 13 times 1 over w plus root 13 plus, let's see, that's a minus, and then plus b, that's just 7 over 2 root 13 times 1 over u minus root 13. And again, that's not u, that's w. This is hard for me to say w so much. I wonder if it's hard for you as well. So now at this point, we can use natural logs to finish this up. So we have ln absolute x squared plus 8x plus 3 minus negative 7 over 2 root 13. That means we really have plus 7 over 2 root 13 ln absolute w plus root 13 plus 7 over 2 root 13. Wait, that's really a minus because this minus sign needs to distribute over here. And that's going to be ln absolute w minus root 13 plus c. We're almost done, but we need to substitute back w, and that means we need to remember what w stands for, and it's been a long time, but it looks like it's x plus 4. So that our final answer here is going to be the natural log of the absolute value of x squared plus 8x plus 3 plus 7 over 2 root 13 ln absolute x plus 4 plus root 13 minus 7 over 2 root 13 ln absolute x plus 4 minus root 13 plus c. Now you might be wondering, could I simplify this? Could I rationalize the denominator? Of course you can. I'm not going to because I'm too lazy. Remember, this was all just one simple integration. The point of this problem, again, was to emphasize we started with the make it right technique, that was our way of rewriting it this way. You didn't have to do that, but we chose to. After we did that, the second part of this became a place where we needed to complete the square. After we did that, it turned into a place where we needed a partial fraction decomposition. After we did that, we were finally able to integrate, and this again was our final answer down here. Hopefully that video helps clear up these various techniques for you. I'll see you for the next topic. Bye for now.